Namaste students, this is Seema Bhardwaj on behalf of Maths Department. In my last lecture, I have started chapter 10, that is circles. In that lecture, I have explained various terms related to circles. I have introduced tangents to you people. I have told what is tangent, and I have explained two theorems to you people. In those two theorems, what we have learned? In theorem 10.1, we have learned that whenever we draw a radius and tangent, this is tangent. Whenever we draw radius and tangent, they are perpendicular to each other. We have learned that OP is perpendicular on tangent AB. And theorem 10.2, we have learned that if we draw two tangents from an external point, the length of these two tangents would be equal. We learn that PA equals to P. Now today we will be doing some examples of this chapter. First example I have taken for you people is, in this example they are saying prove that in two concentric circles, you know, the circles with same center. If two concentric circles are given to us and a chord is drawn for the bigger circle, for the larger circle, I have taken this C1 as the larger circle and AB is the chord. They say if chord is drawn for the bigger circle which touches the smaller circle. Now see, this chord is touching this smaller circle. It is to be proved that it is bisected at the point of contact. Means what we have to prove? We have to prove that AP equals to BP. So I have given two circles C1 and C2 having same center O and radius. One is having radius R and other is having radius Q. Radius is different. And AB is chord for the circle. P is the point of contact. And we have to prove that AP equals to BP. We will have to join OP. Join OP. Now see, AB, which is chord for the bigger circle, has become tangent for the smaller circle. And according to theorem 10.1, wherever this radius and tangent are meeting, it will be 90 degree. So if we write for circle C2, OP is radius and AB is tangent. So we will be having that OP is perpendicular on AB using theorem 10.1. Radius and tangent are perpendicular to each other at point of contact. Now, if again we talk about circle, bigger circle C1, now we are saying that this is perpendicular. In this circle, this AB is chord for circle C1, for bigger circle. AB is chord and OP is perpendicular. And in 9th class we have learned that perpendicular on the chord bisects the chord. In circle C1, the center O and radius R, OP perpendicular AB, proved above, and AB is chord. And we have learnt that perpendicular from the center bisects the chord. That means what? We have proved that This OB is bisecting AB means AP is equal to PB. Implies AP equals to BP. Hence, example, two tangents TP and TQ are drawn to a circle with center O from an external point T. We are given a circle with center O and two tangents are drawn to it, and we have to prove that angle PTQ is equal to double of angle OPQ. So, let us start doing it. Given circle with center O, PT and QT are tangents and P and Q are points of contact, radius and tangent. And we have to prove PTQ equals to double of OPQ. Construction will have to join PQ. Let us take this angle as X and this angle as theta. As you can see that PT and QT, this TP and TQ are two tangents drawn from same external point to the given circle. Therefore, as we have learned in theorem 10.2, that these two tangents should be equal. In triangle PTQ, if PT and QT are equal, then we say PT and QT are equal. That means triangle PTQ is an isosceles triangle. A triangle having two sides equal is an isosceles triangle. If it is so, then opposite angles will be equal. Let us take them equal to y. If two sides are equal, then angles opposite to it are also equal. Let them take equals to y. In this triangle, if we apply angle sum property, so we will be writing x plus y equals to 180 degree using angle sum property of a triangle. We can write 2y equals to 180 minus x, or we can write y equals to 90 minus half x. Let it be first equation. Now, also we know that OP is radius and PT is tangent. And from theorem 10.1 we have learned that wherever this radius and tangent meet, they form an angle of 90 degree. That means this complete angle is of 90 degree. So, can we write OP is radius, PT is tangent, implies OP perpendicular PT, which will imply that angle OPT is equal to 90 degree. If we talk about angle Y can be written as 90 minus theta. This angle QPT. Now straightaway we can write Y is equal to angle OPT minus theta, means 90 minus theta. Equation 2. These two equations are giving us the value of angle Y. So, using these two equations, can we write from equation 1 and 2? Equation 1 and 2. Can we write 90 minus theta is equal to 90 minus half of x? 90 will get cancelled. Shifting to other side or cancelling negative sign, we can have theta is equal to half of x. Shifting 2 to this side, we will be having x is equal to 2 theta. That means what? X what we have taken? X is PTQ is equal to double of theta means what? OPQ. Hence, the next example, PQ is chord of length 8 cm. This PQ is given to be 8 cm. Radius of the circle is 5 cm. T is an external point from which tangents are drawn. We have to find the length of TP, means we have to find the length of the tangent. First of all, join OT. If we join O and T, we have got two triangles. One triangle is TPO and other triangle is TQO. In these two triangles, TPO and TQO, TP equals to TQ, tangents from the same external point. Then TO equals to TO, common. And OP equals to OQ, radii. So, these two are equal, this is common, and these two are equal. So, these two triangles are congruent using SSS SSS rule. Therefore, triangle TPO is congruent to triangle TQO by which rule? SSS, rule of congruency. If we have proved the congruency of these two triangles, then we can say that these two angles will be equal. Implies angle 1 equals to angle 2 using CPCT. Now join PQ, which is given to be 8 cm. If we join PQ and take triangles, let this point be R. Now if we take triangles TPR and triangle TQR, here again TP equals to TQ. How? Tangents from the same external point. Tangents. Then this TR is common. TR equals to TR, common. And angle 1 equals to angle 2, proved above. Proved above. Which implies triangle TPR congruent to triangle TQR. Now by which rule? This side we have used, this side we have used, and this angle. So by which rule? By SAS. SAS rule of congruency. Now if we have proved these two triangles congruent, can we say that these two angles are equal? Suppose AB implies angle A is equal to angle B by CPCT. But they are linear pair also because they are at the same point. A plus B equals to 180 degree. Linear pair. But they are equal also. So we can say A plus A equals to 180 degree. A equals to 90 degree. A equals to 90 or B equals to 90. So we have proved this equal to 90 degree. If this is 90, this will also be 90. All are 90. So if this is 90 means this is perpendicular on chord. We are saying that OR implies OR perpendicular on PQ. We are saying that OR is perpendicular on PQ. That means you learn that perpendicular from the center bisects the chord. So if PQ is given to be 8, PR will be equal to 4. And OP equals to 5 cm given to us. this is 5, this is 4. So if we apply Pythagoras theorem in triangle OPR, we can write 5 square is equal to, why 5 this side? Because 90 opposite to 90 is 5. So this is hypotenuse. So 5 square is equal to 4 square plus OR square 25 minus 16 is equal to OR square 9 is equal to OR square, means OR comes out to be 3. This we have obtained 3. Let us take TP as X and TR as Y. Then in triangle TPR opposite to 90, X is hypotenuse. So X square is equal to Y square plus 4 square. Again, how we have written? Using Pythagoras theorem. So X square is equal to Y square plus 16. This is first equation. Triangle OPT. In triangle OPT, OP is radius and PT is tangent, and we have learned in theorem 10.1 that radius and tangent are perpendicular to each other. So OP perpendicular PT means this angle is 90 degree. If this is 90, then again OPT will be a right angle triangle. Implies OPT is a right angle triangle. So we can apply Pythagoras theorem here also. Here this TO will be hypotenuse, and TO means what? Y plus 3. So we can write Y plus 3 whole square is equal to X square plus 5 square. Again you can write using Pythagoras theorem. Now open the square, it will be Y square plus 6Y plus 9 is equal to X square plus 25. Let us take it as equation number 2. Now if we subtract equation number 1 from equation number 2, this X will get eliminated. We can write again subtracting equation 1 from equation 2, but we will have to rewrite equation 1. This will take this side, Y square plus 16 minus, and here X square minus. So Y square got cut, X square got cut, we are left with 6Y minus 7 is equal to 25. So 6Y, shifting 7 to that side will become 32. So Y is equal to 32 upon 6, implies Y is equal to 16 upon 3. Y means what? Y we have obtained this thing. Now if we put the value of Y in any of the equations, let us put it in equation number 1, we will be getting the value of, if we put the value of Y 16 upon 3 in equation number 1, equation number 1 we were having X square equals to Y square plus 16. So we will be having, in place of Y we will be having 16 upon 3 whole square plus 16, opening the square 256 upon 9 plus 16, taking LCM we got 400 over 9, and the value of X comes out to be 20 upon 3. X means what? PT is equal to 20 upon 3 centimeter. This is what was being asked.